Hello guys, hope you all are doing fine and welcome back to the module on applied probability and statistics. So let's begin. So I'm assuming you have gone through the previous video, and if you have, then I am assuming that you already know what a random variable is, what a probability distribution is, what's the sense of discreteness and continuity. Okay, so from there let's proceed ahead, and now we will look into some widely used discrete probability distribution. Okay, so now you can see that here is a word called standard also. Okay, so by standard I mean it is well known or known in the same form. Okay, so when I say Bernoulli distribution in India, it has the same meaning in New York or any part of the world. Okay, so that is the meaning of standard. Okay, we have standardized. It is a well known and everybody knows in the same form. Okay, also in the same, sometimes also in the same notation. So that's why the use of the word standard. So just clarifying on that, it's a discrete standard probability distribution we are talking about. So let's move ahead. Uh, the first distribution, called the Bernoulli distribution, is also one of my favorite distribution, or I think it's also the most widely used distribution. Okay, so x just denotes here random variable. Okay, so it will take some outcome. So here the outcomes are 1 or 0, or we can also label it via string, that is head or tail. Okay, but what defines this distribution is the parameter p. The p here just denotes the probability of this variable taking 1 or 0. Okay, so the question is, what is the probability that this random variable will take 1 as outcome or 0 as outcome? So that is decided by the probability p. This is also, I can say, this is the truth of the coin. Okay, so why I am interested in knowing the truth? Because actually the whole world of data science, AI, everything is just fighting for knowing this value p, that is the truth. Okay, why? Because based on that we can take some decisions. Okay, based on the truth we can take some decisions. So of course knowing the truth is not an easy task, so we do something, we fight, we put effort to getting close to the truth. Okay, so we will talk about this. This is the essence of whole statistics. Okay, so we want to know the truth, we want to know the value of p, because based on the value of p I'm going to take some decisions. For example, let's talk about a scenario. Okay, everybody watches IPL, right? I'm assuming maybe not. So let's assume you watch IPL and you are booking a ticket for the match. Okay, so uh, just think about it. What happens if there is rain on the day of the match? Will the match happen or not? So these are something random phenomena. You don't know with certainty whether the match will be played or not. It will depend on the weather condition. Okay, but before booking the ticket, if I know whether it will rain or not, I can take a decision to book the ticket or not, right? Why? Because if I am able to estimate, note the word estimate. Estimate is getting close to the truth value. So if I am able to estimate this p value, okay, then I will decide whether to book the ticket or not. Suppose it is most likely to rain that day, I will definitely not book the ticket. That way I also will be rewarded. So there are two things. Okay, one is decision and the second is reward. If you are able to get close to the truth, you can make a good decision, and for the good decision you will be rewarded. So whether you want or not, there is always a decision involved and the reward involved. Okay, so that's all about Bernoulli distribution. It's nothing, very simplest distribution, just a coin toss distribution. Okay, that's what I'm care about. Let's move on to the next, binomial distribution. Okay, uh, let's understand it in its simplest forms. Basically, suppose you toss the coin 10 times. Okay, you toss the coin 10 times, and I am interested in knowing how many times head will come in 10 coin toss. Okay, so n represent the number of times I am tossing the coin, and what does this variable says? This variable will take values. Okay, either it will take head or tail, that's the coin toss. But this is not this variable is telling. This variable is telling how many times head has come in n coin toss. Okay, or how many times tail has come in n coin toss. So now I am interested in counting. Okay, rather than getting involved in head or tail, I am involved in counting how many times head will appear or tail will appear in n coin toss. Okay, so again there are two variables. Okay, first is the how many times the coin is being tossed, and the second is each time the coin is tossed it will take head or tail with parameter p, that is the success probability or probability of head or probability of tail. Okay, so what is the application of this distribution? Let's come to that. Yeah, reaching airport. Suppose you are a very rational person. Okay, you have a flight to catch. Suppose today you have a flight to catch in 3 hours. Okay, and suppose while in the journey of reaching the airport there are 3 traffic lights. Okay, so based on whether I will be stuck at 1 traffic light or 2 traffic light or all the 3 traffic light, I will decide whether to leave early or more early, okay, or less early, right? Because that way, that way I will be like saving my time or ensuring that I reach the airport on time. Okay, so suppose from my house to the airport 3 traffic lights are involved. Okay, and somehow if I know that I will be stuck in all the 3 traffic lights, of course I will leave for the airport early, right? So that is the decision making. Okay, if I know that all the 3 traffic lights, I will not be stuck in any of the 3 traffic lights, then I can leave a little late. Okay, save some time. Okay, for whatever reason. So that is the example of decision making, and for that I will be rewarded, right? Suppose I do not take into account that I will be stuck in all the 3 traffic light, I might get late, I might miss my flight, so I will be negatively rewarded in that case. So always know that 2 things are involved. Okay, decision making and the reward, whether you want or not, that is there. Okay, so if you take that into account, it will be helpful for you in some way. Okay, there is another example. Suppose there is a shopping mall, okay, and 1,000 people comes every day. Okay, so I will be interested in knowing whether all the customers will buy stuffs or not. Okay, whether 1 will buy, whether 2 will buy, whether 3 will buy, or all the 1,000 will buy. Okay, so that way the shopkeeper can maintain its inventory. Okay, it will not keep too much inventory or too less inventory. Suppose the inventory is meant only for 10 people and 1,000 people are coming, so about the 990 people won't get the stuffs, right? So this is also a relevant distribution for this scenario. So it is very important whether all the 1,000 people are going to buy or not, because each customer is like a coin toss, whether he or she will buy the stuff or not buy the stuff. Okay, so every customer is a coin toss, and there are 1,000, the coin is like being tossed 1,000 times. So I am interested in knowing how many times the customer will buy the stuffs. So for that reason it is important. So I have given you 2 examples, 2 relevant, 2 real life example of binomial distribution. Let's come to the next one. Negative binomial distribution. Okay, this is also a very interesting distribution in the sense, for example, you are hunting, let's come to the example, but before that let's see what I have written here. Yeah, again this is a counting variable. First understand this is a counting variable. Okay, this denotes how many failures occur before a specified number of successes is achieved, say r successes. Okay, let's fix the value of r here 1. Okay, so what is the meaning of this in this sense? How many times you have and let's say success denoted by head, how many times you need to toss the coin before you see the first head or the first success. Okay, so basically it counts how many times you will fail before you achieve your first success. Okay, again it is a coin toss and there are 2 variables, that is the r success, or how many times you will fail before achieving 3 success. Okay, so r is here parameter and another parameter is p, that is the probability of success or failure. So let's see the example. Cracking job interview. Okay, so suppose you're preparing for an exam, okay, and somehow you are able to evaluate yourself and assign a probability that you will crack a job interview. Okay, if you know that your probability of cracking the interview, then possibly you also know how many interview you have to give before you get the success. Okay, so this is the decision making. Okay, but the reward is also there, because suppose you are just giving interview again and again and you're not achieving the success, and then you get mentally disturbed, you get demoralized, right? You get depression. So these things you can escape if you well know the probability of cracking the job interview, because that way you will be mentally prepared that yes, I have to give at least this many interview before I crack the actual interview. Okay, so that way that is the reward, because you will be mentally prepared, you will not be disappointed or you will not be like demoralized. But that is the reward. Okay, the reward here is like your mental satisfaction, and also the development or improvement in your strategy of preparation. Okay, so I hope I made it clear, but if you have got any doubt you can comment it. I will respond to that. But in simple words, this means is what this means is how many failures you are going to face before you get your first success. Okay, so every coin toss is like a head or tail, or success or a failure, and this distribution x counts. This just gives you the count how many times you will fail before you get your first success. So this is all about negative binomial distribution, again a very relevant distribution, okay, in data science and AI field. So with this I have come to the close of this video, but before I close this I am giving you two recommendation, because this video I am making is very much simplified, and if you are interested in going into the details, mathematical details, so for that reason I have put two here. Two recommendation. First is the IIT Kanpur lecture notes MSO 201, which I did in my times in my college, yeah, same college of course, IIT Kanpur, and this is the most widely followed notes, okay, by all the students of the IIT Kanpur. Even the new faculty or same faculty of similar experiences takes the course, he follows it. So this is one of the, I think, best possible notes available, openly available. Another recommendation is this book. So with that, thanks a lot. If you like, thank you.